All right, so let's go back, deal with various functions right here. Let's deal with the cosecant function this time. The cosecant function, remember, is the reciprocal of sine. So if we've got a cosecant function and we're going to shift that with a phase shift right here, well, as a guide, we can use the similar graph of sine, right? So if we're using a sine, let's say, well, what would it look like if we were to decide to sketch the function y equals sine of x over 3 minus pi over 2. Okay, so if we know something about that one, we know something about the other, right? Because wherever our vertical asymptotes occur is where the sine of x is going to be crossing the center axis. So what could we say? Well, all right, x minus pi over 3. Or sorry, if we x minus pi over x over 3. Good Lord, I'm having a good day. If we take this, right, where our period for this sine function is 2 pi over 1/3, which is to say 6 pi. So this is one cycle of the graph. Now, if we wanted to deal with key points, of course, the key points are going to be spaced at 1/4 of that period apart. So 1/4 of 6 pi multiply together, reduce, gives you 3/2 pi. But there's also a phase shift right here, and our phase shift is found by setting x over 3 minus pi over 2 equal to 0, and then solving for x. Well, doing that here gives us x equals 3 pi over 2. In our graph, that's going to give us a starting point for our x values. Our x values, at least within one cycle, are going to start at 3 pi over 2, and each of the key points themselves are going to be spaced 3 pi over 2 apart. So let's see, 3 pi over 2 plus 3 pi over 2 is, well, 3 pi. Plus 3 pi over 2 gives us 9 pi over 2. If you need to pause and work those through on paper, you probably should. 3 pi over 2 plus 9 pi over 2 gives me 12 pi over 2, so that's 6 pi. But we need to add one more in so that we have a total of 5 key points. So if we take 12 pi over 2 and add 3 pi over 2 more, we get 15 pi over 2. Okay. Now, for the sine function, if this were a sine function, for the y values, we'd be thinking to ourselves, 3 pi over 2 is the first key point on a sine function, goes 0, then it goes 1, then it goes 0, then it goes -1, and then it goes 0. But in this case, we're actually dealing with cosecant, right? So anywhere where the cosecant was equal to, where the sine was equal to 0, the cosecant will be a vertical asymptote. So we get vertical asymptotes at 3 pi over 2, and 9 pi over 2, and 15 pi over 2. That's kind of interesting that's happening. What could we say about the domain? Well, again, if you think about the basic function, y equals sine of x, I'm sorry, y equals cosecant of x, in y equals cosecant of x, our domain was found by setting that value of x such that x is not equal to some whole number, some integer multiple of pi, right? X does not equal n pi. In this case, if we were interested in finding it, what we're going to do is that we're going to take the argument x over 3 minus pi over 2 and saying that cannot equal n pi. So what does that mean to us? Well, if we isolate by adding pi over 2, we're going to get x over 3 cannot equal n pi plus pi over 2. And this means that x, our domain right here, will be the values of all x such that x is not equal to, multiplying by 3, 3n pi plus 3 pi over 2, which seems like a horrible conglomeration to have to work with. But maybe another way of putting this is to look at this as being the set of all x such that x cannot equal 3 pi times n plus 1/2. If you wanted to simplify that out. So how is this going to look on our graph? Along our horizontal axis, we're going to get marks at every 3 pi over 2, right? So let me see, if I'm putting my key points, try that again here. If I put key points strategically around right here, let's see, 3 pi over 2, let's make every other mark a good one for us. Our key points, if we're starting at 3 pi over 2 for one cycle right here, we're going to get 3 pi, we're going to get 9 pi over 2. We're going to get 6 pi, we're going to get 15 pi over 2. So one cycle, following the locations of our vertical asymptotes, we can use what happens with the sine function as a guide right here, and I'll do that in green. The amplitude is 1 for the sine function, so here's 1 and here's -1. So in green, the sine function does like this. Get that to go in the right direction. There we go, something like that. And so our cosecant function within that one cycle will look kind of like this. That is exactly one cycle. We would have more cycles going either way right here. Coming off to the right, for example, we could have another cycle going, or coming off to the left, we could have another cycle going through 0, -1. All kinds of things that we can do right here to get an idea of what the rest of this graph looks like over more periods. But here's the graph as we use the sine in order to help guide it.